All right, welcome to Unit 2 of the spring semester PreCal seniors. This is day 2 notes, where we're going to add a little bit more to what we know about vectors. So if you look at the instructions, the first thing you might see is I and J. So what is I and J? Well, vector I, which sometimes looks like that, and usually when we write it will look like that. If you want to be fancy, you can put a little arrow on it to signify that it's vector I. Well, this is a unit vector, which is a vector of length 1 in the x on the x-axis. So that vector is the vector 1, comma 0. So if you were to plot the point 1, comma 0 and draw a vector in standard position, it would be a vector of length 1 on the x-axis. And if you think about it, vector j is going to be on the y-axis, so that's going to be 0, comma 1. There are three-dimensional vectors that you can also do, like vector k, but that will be on the z-axis, which again is three-dimensional, which we're not going to cover in this class, but good information to know. So what we can do is we can do a lot of stuff with vectors in what we call the sum of two components, the ij form. So like, for example, if I ask you to add c and d, well, vector c is 3i minus 4j's. And again, you can draw the little hats on it if you want to. Vector d is negative 5i and 12j. And literally what we can do is just add those two together. So we'll just combine the i's, get negative 2i, and combine the j's and get 8j. And that's it. That's all you need to do. If you don't like that, you could also do it in the component form, where you can do 3 comma negative 4. You can do negative 5 comma 12. Add those up and get the exact same thing of negative 2 comma 8. The only thing you cannot do is combine these two together. I have a lot of students in the past that either put i's and j's inside of the chevrons, or they don't include the i's and j's in the sum of two components. So just make sure that those two are completely different. You need to keep them separate. There are no commas in the ij form, and there's no i's and j's in the component form. Well, what's nice about this is that you can do this with any kind of operation. So if you have vector d minus vector c, I'm going to write it a little differently. So negative 5i plus 12j is vector d. Vector c is 3i minus 4j. And I'm subtracting the two. Well, if you're subtracting a binomial, this binomial needs to be in parentheses, because what you need to do is distribute that negative into both terms. And then you combine like terms. And again, if you want to, you can use the component form, the one with the chevrons, and do the exact same thing. And then it can get a little bit more challenging, which again, I'm going to write like I did in the last problem. I'm going to take vector c, which is 3i minus 4j, and multiply that by 3. I'm going to take vector d, which is negative 5i plus 12j, and I'm going to multiply that by 4, and I'm going to subtract that. So almost like it's an algebra problem where we give you a bunch of terms and tell you to combine like terms. So you end up getting 9i minus 12j plus 12i's, or sorry, negative 4 times negative 5 is positive 20i. And then negative 4 times positive 12 is negative 48. Well, my writing's not doing what I am asking it to do. And then if you combine your i's, you get 29 i's. If you combine your j's, you get negative 60 j's. And that's it. That's how you do those type of problems. Now, something that some textbooks have in math are these double vertical bars. And you kind of might have seen this notation in the last day of notes, where it was just one vertical bracket like that. Either way you write it, it's called the magnitude. So the magnitude is that formula, the square root of x squared plus y squared. So for vector c, our x component is 3, our y component is negative 4, and so I square those and add them. And remember that either ignore the negative or put your negative numbers in parentheses. So 3 squared is 9, negative 4 squared is 16, so if you add those up, you get 25. So the square root of 25 is 5. So the length of vector c is just simply 5. What about vector d? If you look for the magnitude of that, we have negative x, or negative 5 for our x. and then positive 12 for a y. If I square those and square root it, you end up getting negative 5 squared is 25, 12 squared is 144, so then you get 169 inside the square root, which is simply just 13. So that means the magnitude of vector c is 5, the magnitude of vector d is 13. If you add those up, you get 18. So that's the magnitude of vector c plus the magnitude of vector d. But something's a little different with this one. Number 5 is asking us to find the magnitude of vector c plus d, which we did earlier. The addition of vector c plus d is just negative 2, 8. So if I'm going to find the magnitude of this vector c plus d, I'm going to square root the x squared, which is negative 2, the y squared, which is 8. So you get 4 plus 64, which is 68. And again, however way you like to simplify radicals, I like to find the biggest perfect square that goes into 68, which is 4, which is multiplied to 17, because then if you square root those, you end up getting the square root of 4 is 2, the square root of 17 is root 17, and that's the magnitude of vector c plus d. Now, notice that those are two different answers. Number 4 is asking you to find the magnitude of c, the magnitude of d, and add them up, where 5 is asking you to find the magnitude of them already added up. So we're going to kind of visualize this on number 7, but let's do number 6 first. So number 6 tells us to do 3 times vector d, add it to c, and then take a sixth of all of that. So just like the order of operations, what I'm going to do is I'm going to start off with the innermost parenthesis. So I'm going to take vector d, and I like doing the sum of two components form when you're doing stuff like this. So vector d is negative 5, 12. Multiply that by 3. And then add it to vector c, which is 3i minus 4j's. So let's see if I can make sure to say this and write down exactly what I want. So 3 times negative 5 is negative 15i's. 3 times 12 is 36j's. And then adding these. So then I end up getting negative 12i's plus 32j's. So that's the insidemost parenthesis. Now, what I'm going to do is I'm going to take a sixth of that. So a sixth of negative 12 is negative 2. A sixth of 32, well, that's 32 over 6, which ends up reducing to 16 thirds. Yeah. And that's our final answer for that. So how is number 4 and number 5 different? Well, we're going to learn how to sketch that. So what I'm going to do is I'm going to sketch vector c plus d, which we did earlier. C plus d was just negative 2, 8. So I'm going to go negative 2, 8, and then draw my vector. And that is what we call our resultant vector. That is vector c plus d. But how would I do that if I just had vector c and vector d? Well, vector c is the vector 3, negative 4. So I'm going to go 3, negative 4. And the crazy thing is that these are all supposed to connect with each other. So this is vector c. So in order to add vectors, they have to be something that we call head to tail. So you start with one vector, like I started with vector c at the standard position at 0, 0. And I went to its ordered pair and drew that vector. So 3, negative 4, there's vector c. At the end of this vector, that is what we call the head. So that's the head of the vector. So that means that in order for me to draw this head to tail, the tail of vector d is going to be here. Well, vector d is negative 5, 12. So what I'm going to do is, starting here, I'm going to go negative 5 in the x direction, which means left. So 1, 2, 3, 4, 5. And then up 12 on the y direction. So from here, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And honestly, coincidentally, whatever you want to call it, they all connect. So that is the difference between graphing vector c plus d and graphing vector c plus vector d. So it's almost like telling somebody directions, like you're starting at the same spot, but you tell somebody the long way around. You go this way, you go like left 3 blocks and then down four, then you go left 5 blocks and up 12. Um, or you could have just told somebody, hey, go two to the left and eight up, and you would have ended in the exact same spot. So this is what vector addition looks like. We are going to ask you to do stuff like that, and we need you to show all three of the vectors. And again, they should kind of connect and they form a triangle. So what is the magnitude of this resultant vector? So they're saying that the resultant vector is called vector R. Well, we already did that earlier. That's the same thing as the magnitude of C plus D, which is number 5 in our notes. So we end up finding out that that's 2 root 17. Because again, you have the work already for number 5. Then the direction angle is what we did last class. We're going to do inverse tangent of the y value of the resultant, so 8, and divided by the x, which is -2. I'm not going to show it on here, but in your calculator, you should put it in your calculator and end up getting -75.964 degrees, which, if you remember from our unit circle, is not the correct direction because -75.964 would be somewhere in quadrant 4. We need it to be in quadrant 2. So how do we do that? Well, we add 180 degrees, and if you do that, you get 104.036 degrees, which makes a little bit more sense based on our drawing that our resultant vector here in quadrant 2 is somewhere between 90 and 180 degrees, which 104.036 degrees is. All right, so I kind of already mentioned this thing called a unit vector. A unit vector is a vector that has a magnitude of 1. Okay, so just we need to make sure we have a magnitude of 1. So how do I find a unit vector, a vector of length 1, in the same direction as vector d? So this is the same vector d that we talked about before, the vector -5, 12. And what I'm going to do is I'm going to roughly sketch that. So -5, 12 looks something like this. But a unit vector is the same vector in the same direction, so like here, but the magnitude of that vector is 1. So how would we go about finding out the x and y component of this little tiny vector that has a length of 1 that goes in the same direction as our vector d? Well, we're going to follow these steps. We need to find the magnitude of vector d. Well, the magnitude of vector d is taking the x, -5, squaring it, and adding it to the square of the y. So again, like what we did earlier, 1 square root of 169, which finds out that the length of this whole vector is 13. So in order to find this unit vector, what I would do is take that whole long vector of 13 and divide it by 13, and I end up getting 1. But if I'm going to divide that vector by 13, I need to divide every part of its vector by 13. So we're going to divide the x part of our vector by 13, our y part of our vector by 13, and then you pick whatever format you like. Do you like component form, which is this? Do you like the sum of two component form? And that's the unit vector. That's it. So if you want to visually see this, also what I'm doing is I'm kind of taking this triangle. Let's see how well I can. Okay, that's pretty good. So this is -5, this is 12, and this was 13. But what I needed to end up doing was finding a triangle that kind of matched up with that triangle, but had a hypotenuse of 1. Well, in order to do that, you're taking this triangle and I forgot the word, dilating it down to a similar triangle, and you do that by dividing all the side lengths by 13. So that's how we end up getting that unit vector. Well, what's the point of having a unit vector? Well, it's like going to the grocery store and buying vegetables. You can't just say like, oh, well, you have 6 pounds of apples for like $10. Well, you don't want 6 pounds. You only want, 3 pounds. what would be nicer of to know? Well, how much each pound is. So this unit vector is how much 1 pound of apples cost. And if you want to go and buy 7 pounds of it, you just literally take that and multiply it by 7. So I'm going to take this unit vector of -5 comma 13, or -5 over 13 comma 12 over 13, and multiply both of them by 7. Well, if you're multiplying 7 by -5 13, you multiply the top times the top, so -35, the bottom times the bottom, which the bottom of 7 is 1, so 1 times 13. Then you do the same thing with 7 and 12 thirteenths. And then that is a vector in the same direction as vector D, but has a length of 7. So again, we just found a unit vector that has a length of 1, multiply that by 7, and got that. And what you can do is you can find the magnitude of each of those. The magnitude of this unit vector should come out to 1. The magnitude of this should come out to 7. So in class, I would ask you to try to do the exact same steps, but for vector C. But we have a video here. So find the unit vector of vector C. So the first step is to find its magnitude. So square root the x plus the y squared, which again, 9 plus 16 is 25. You square root that, you end up getting 5. So that means the length of this vector is a length of 5. So what you need to do is take the x component, 3, and divide it by the magnitude of the vector, 5. You're going to take the y component, which is -4, and divide that by 5. And that's it. That's the unit vector. So make sure that you ask questions, practice this in the assignment. Good luck.